there we can see Eduardo. Buenos días a todos. ¿Qué tal? Esta es una nueva charla de conferencias técnicas de la SPE. Hoy tenemos un orador americano, con lo cual vamos y hay bastantes personas anotadas que son de afuera. Vamos a pasar al inglés para que todos puedan entender. So, thanks for coming. My name is Fernando Tuero, and today I'm with Eduardo Ruiz as a moderator and John DeWart for today's talk. So this is one more of the series of technical lectures that we are providing here through the SPE Argentina to try to make access or spread out the best practices for every interesting topic that we craft here in the SPE. So today's talk, it's called Drilling Automation Systems, Where We Are. And we would like to thank our sponsors, YPF, Pan American, Equinor, San Antonio Internacional, CGC, Oldelval, Exxon, Chevron, Tecpetrol, Emerson, Industria Seco, and Halliburton. Having said that, the talk will be around an hour in terms of time. Then we will open the space for Q&A. And the best thing, or the best way to do it, is maybe that you right away, when you figure out a question in your mind, you just pop it there in the chat we have in the meeting. So you can put the question there, and the moderator will read the questions afterwards, and he will select the most interesting questions and make the questions to John, who's going to answer your question. So I leave you with Eduardo, that he's going to present today's lecture. Eduardo, your turn.
Good morning. Good morning. It's a pleasure to me to present John. We know a lot of people in the industry know John. But to begin with, what is drilling system automation technical section? It's a technical section of SPE to promote the automation in the drilling industry. We want to encourage to participate all the people that is in the as SPE member. As Fernando said, today's talk is implementing drilling system automation. Where are we? A little bit about the big story about John. John has 48 years of management and technical experience and has worked in 36 countries. He's a chartered engineer, a fellow of the Institution of Mechanical Engineer, a distinguished member of SPE, and Director Emeritus of SPE Drilling System Automation Technical Section, DSATS. Well, we have a lot. If I continue reading his CV, I'm going to spend all the time. So I let John, and welcome John to this presentation.
So good morning, good afternoon, everyone. Hope you can hear me well. My topic today is implementing drilling systems automation and raising the question, where are we? So the presentation introduction. Today's presentation is going to focus on the status with a short history and some outlook. The main focus is the status. And as everybody knows, SPE policy prevents company names and trademarks in published papers, but it does permit company names in technical talks, which are published by SPE. And this presentation follows the tech talk model. So I just want to note that when I include company names, it does not necessarily mean endorsement. And if a company name is not included, it doesn't mean non-endorsement. So it's just the examples are there with the company names, so you're able to follow up afterwards. And I'd like to thank Nestor for organizing this event in his role as the South American DSATS program chair. A couple of sources of information for you where you can find more details is the Drilling Systems Automation Roadmap, which has been published at www.dsaroadmap.org. and a portal that we created and that I manage, which is an access to information, current information and past information on drilling systems automation. And you can find that at www.dsaboc.org, which stands for Drilling Systems Automation Body of Knowledge. It's an industry open reference for people to go and look at. So I start out here with something I mentioned in the abstract, is an automated drilling rig, the NADM, the National Automated Drilling Rig, which is actually published in the Oil and Gas Journal in 1971. I visited this rig in 1981, and it was operating in South Texas in the early 80s. So I call this back to the future. And if you look at this rig, you probably recognize that it's a super single style rig. This is the Walker Near Apache rig. It was actually a fully hydraulic rig, which was driven by swash plate pumps as the power source. It had limit detection switches. So all the motion of the components, the limits were detected by these switches, which have a wheel on the end of them. And when they get impacted, they raise up and they switch on or off. And the thing about that I raise is that a lot of the drilling fluids got into these switches and caused issues, reliability issues. And then the computer cabin, actually, the computer was electronic valves, as we say in English, or tubes, as you say in American. So every time they move from location to location, these electronic valves or tubes got broken and they had to put them back together again. So the computer running this thing was pretty historic. And as I said, it drilled a series of wells in South Texas for Mobil in the early 80s. So it proved it could do it, but the reliability just wasn't there. Then what happened after that is that oil companies launched initiatives, and Shell had what they called SCADA drill. And it became a significant global initiative. They did a lot of work with Chinese rigs. They did a lot of work with other drilling contractor rigs. They built a complete suite of applications. They tested them, and it was all very successful. But then they suspended this initiative. And essentially, they found it was too much work to go to all the different rigs with different control systems and implement their automation system. They have licensed SCADA drill to some others. There's a couple of companies I've seen that have got it, but I can't find the status of that implementation today. And then Apache in Texas, they automated a Houseman LOC land rig, which had an integrated control system. They did some very successful tests, and then they suspended this automation program. They licensed rig designs that they had developed from their experience of doing this to Canyon Oak Energy, and so far I haven't seen those rig designs come out into the market. And then Apache switched their focus to data analytics. So if you watch what they've been doing and watch what they've been publishing in SPE papers, it's been primarily focused on data analytics. So the automation platform development shifted to drilling contractors. And then app development is occurring with drilling contractors, service companies, and now software as a service startups. So that gives us the kind of framework as to where we are today. So what opened the door in the 2000s to advancing drilling systems automation? Basically variable frequency drives, which delivered improved control. And with improved control, we got joystick control on rigs. Pumps were being pre-programmed for startup. I don't think a lot of people realize this, but they were programmed in the rig up yard, and that programming could be changed in terms of the ramp up of the mud pump. And then automated tools became fairly common, rotary steerable tools. And we saw advisory and then closed loop directional drilling. So the directional drilling data was being analyzed, processed, and given as directions to the directional driller in an advisory mode, and subsequently closing the loop. And rate of penetration optimization was actually accomplished prior to 2012. There was a presentation at an SPE workshop in 2012 on a system that Schlumberger had developed, rate of penetration optimization, which they showed in their graphics actually was very successful. Again, they started with advisory mode, then they shifted to closing the loop. And what's happening now as a flag for me is that remote operations and automation are beginning to combine in order to deliver more value. And what are the business drivers that are advancing rapidly that impact automation? Well, digitization. And here I want to distinguish between digitization and digitalization. Digitization is to convert something into digital format, such as data or documents, whereas digitalization is to convert business processes over to use digital technologies. So you get a change in the process deriving from the digitization of the data and the documents. And then I put automation at the next level, which is where we want to operate with minimum human intervention. So once we've digitalized, then we can automate. The business model is changing. Land drilling contractors are adding services, and you'll see in North America, a lot of them offer directional drilling, which is now automated, survey quality management, drilling dynamics analysis. We see that they're also requesting payment for outcomes. So the deliverable from the well, so the quality of the well, the quality of the well bore, and not simply getting a day rate payment. And one drilling contractor at the SPE-IDC drilling conference in Galveston this year responded on a panel session to a question I posed by saying that 50% of their US land rigs now have reward schemes. So the interesting point about this is that automation does improve performance, but it also improves the outcomes and reduces NPT. So when it starts to improve the outcomes, there are now reward schemes in place that can reward for the investment in that automation system. And collaborations are appearing across the industry. I would tell you that this has now become a trend, and it's moving rapidly, and it's becoming very intricate. So what we can see is Corva, which was a startup company from, I'm going to guess, 7 years ago, and is a software as a service company, has collaborations with Neighbors, a drilling contractor, with Patterson UTI, another drilling contractor, with Baker Hughes, a service company, and then with 3 companies in the fracking side of the business, Drill2Frac, Cold Bore, and NextHit. Halliburton have collaborated with Hess and with Neighbors up in the back and on their digitization of drilling. And now they're collaborating with Neighbors on the automation of drilling rigs and automation of drilling rigs in very remote areas. So SLB announced a collaboration with NOV, and I'll come back to that later on when I introduce what they're doing. And then Equinor has been working with Transocean and HMH. The other one that I think is really interesting, if you want to follow what's happening in digitalization and automation, is Aker BP's alliances with Odfjell for drilling and Maersk, which is now Noble for drilling, 2 different types of rigs, and then both Halliburton and Schlumberger, and they are making significant advances. And here we start to look at this transition that's occurring more from the technical side. And this was created by Scott Boone and Maury Lang, that they produced this, and then we put it into a SPE paper on business model reconstruction that we published a couple of years ago. And what we can see was historically on separate products, the industry has been competing. So differences between motors, rotary steerables, etc. And then we get to this complement stage where we get interconnected services. So remote directional drilling, geosteering, vibration mitigation are some examples. And then we get to collaborate. And here we see new solutions. And in that we see automation agents, open source models, and then we start to see connected well plan delivery. So everybody's being pulled together through a digitized and then digitalized system to create well plans. And this is now actually moving up to the next level of field development planning. So what we can see here is that companies in the digitalization space are now collaborating, and they're collaborating with multiple different companies in the same sector of the business. One thing for automation is there's a need for interoperability, and it's about the data, but it's also about the control of the systems. And in the past, we looked that there could be an integrator path where the single supplier owns and controls all the equipment and systems. Or it could be the operator who believes the value proposition, or the drilling contractor with key services and advanced software. And what we saw was the single supplier avenue was chased by Schlumberger back 5, 6 years ago, when they invested a lot of money in buying a rig design company and doing a JV on a rig development, buying a controls company, and actually aiming to put together what they call the rig of the future. And that has gone by the wayside. So they've now changed their direction. And then the two operators I gave the examples of, they believed in the value proposition. They did go about developing it, but then they stepped back from it. And now what we've seen is the drilling contractors are coming forward, and I'll show you examples with both key services and the software systems to run the rig operating system. And then we see collaborative path, which is multiple companies working together. And I would say today that we're seeing the drilling contractor bringing the automation platform, and then the collaboration with the various service companies and software providers in order to deliver an integrated result. So we've seen the operating system from original equipment manufacturer or the original system builder is now predominating. And my lesson is, if you build rigs, build an operating system, or some people call it an automated drilling control system. And here's the graduation to this interoperability as shown by DWIS. DWIS is the Drilling and Wells Interoperability System, standard, which is a subcommittee of DSATS. And they've been in operation with volunteers developing solutions for the last 5 or 6 years. And they show running from manual operations where we have rig control systems, PLCs, sensors, and actuators, to the next step where we go into automated with the automated drilling control system with its own apps. And then we get to interoperable, where there is an interface that the DWIS group have been working on that can connect third-party applications and third-party equipment to the ADCS, the automated drilling control system. And this is a diagram showing how this all works. I know it's pretty complicated, and my recommendation to you is go to d-wis.org. They have their own website, and on there they publish a lot of their information, which you can go and see and catch up on. The other thing is to know that in the fourth quarter of this year, I think in October, they will be running a demonstration connecting their setup to different ADCS systems from different manufacturers. So we'll see a demonstration in the virtual world, which people can attend. If you have a look at this, we have these drilling advisors, so directional, tripping advisors, drilling itself advisors. Up here, we have downhole measurements, fluid properties. We have the well plan, the drilling section plan, etc. So there's all this information from advisors, data acquisition, and from contextual sources. And then on the left side, you can see the drilling process state interpreter. And actually, this group has published a paper on microstates in drilling. So they can actually define to some detailed level the process states that are occurring. So this can go into the central hub of the system and everybody knows what's happening. There is a scheduler doing sequencing. And then there's an advice composer, which is bringing together safe operating envelopes, failure detection, identification, and recovery, which is coming into the system as well. On the right-hand side, we see a logger, which is capturing all the data as it's produced. And this DD hub in the middle, which was developed by Norse, is a method to bring all this data together. Each data source has semantics attached to it, which is similar to metadata, but gives a story about the data. So when you receive data, you know where it's come from, you know how it's been collected, you know how it's been processed, and then the data can now go and be used to drive the ADCS capabilities and interfaces in order to drive the automation. So this is a model being developed that can actually cause interoperability between various different companies who have different systems themselves. And I would say that the value proposition is being delivered in automation, drilling systems automation. So safety, we've got less personnel in the heavy machinery envelope. And I'll show you an example where there's nobody on the monkey board and there's nobody on the floor. Efficiency improvements. One of the biggest improvements is through consistency of repetitive operations. And as most people know, if you start to plot a graphic of the time to do an activity against the number of activities, you will actually find a distribution which on the upside is a fairly steep slope, but on the downside is a very long tail. And the long tail causes the mean to move to a higher level. Automation can actually diminish that tail by making it more consistent and more of a Gaussian distribution. And by doing that, the mean moves to a higher level. So actually consistency of repetitive operations becomes faster operations. Process safety. So borehole envelope protection reduces NPT. So when the system is looking and saying you shouldn't cause swab or surge higher than this, your ramp up of your pump should be like this in order to avoid surging with the gels, etc. When you break the gels, then you actually save the borehole, you reduce the NPT. And making the load on the driller much better, moving the driller actually to supervisory control. So he's not sitting there doing a really routine operation that the system can do for him. He's operating at a higher level, supervising the system and able to take those bigger decisions. And then influx detection has come in with a company that offers a service to do this, and they connect it into the rig control system, and it's automated and it acts fairly quickly or very quickly, but it also allows override by the driller. So it's still under the driller supervision, but the system is there that can actually catch an influx quicker than the human being. And this is a big plus, but yeah, it's interesting that the adoption hasn't been as fast as one would have anticipated. And I think, attention is now moving to wellbore quality, and particularly in long laterals. I mean, we were talking yesterday in an IADC Drilling Engineers Committee about 6 mile laterals, 6 miles. That's a long way to drill in a controlled manner that delivers a wellbore that is usable. And there's impacts of how much is in the reservoir, but also what is the tortuosity. And companies are now addressing that through their automated system, but there are other things to be addressed, such as porpoising, which is the wellbore going up and down, causing liquid dropout. The liquid dropout keeps slugging. The slug eventually shuts down the separator. So it's a deal that has a huge impact on the productivity of the wells and production operation that's not seen by the drillers. So this is an area that is going to be developed more. And data is being blended across solutions. So people are really beginning to share data and put it into a common envelope. So if I go through various companies that have been involved, NOV's been in this for a long time. And they started out with a closed downhole automation loop using their hardwire system, and their process automation system in Novos was sitting on top of that. Novos now runs without the hardwire system. So you can run it with the hardwire, with the downhole data, or without the hardwire. And things that they do is tagging bottom. So the driller has control points to specify how he engages the formation. And then true downhole weight on bit, and then also minimizing drilling dysfunction. And I'll come back to some of these common applications we're seeing. People used this to do analysis, and they ran the system actually to gain information on how to drill wells better, and then took it across to other wells without the hardwire system. Precision drilling is a heavy adopter of the Novos system. When I come on to precision drilling, you'll see what they're doing with it, with the applications and some of the results that they are publishing that they have achieved. And then users can configure their application to Novos. So I think originally people saw Novos as more of a closed system, but now users can bring their application to it and input their own automation to it. So Novos applications today, the ones that I found, and somebody might say there are more, maybe there are, but directional trajectory, so directional control, oscillation and off-bottom RPM, so minimizing drilling dysfunction, circulation on and off bottom, drilling the stand to set points, tagging bottom. This is a huge one. This is the process of actually bringing the bit into the bottom and recommencing the drilling process, which has a huge impact on mean time between failure of the equipment that's running in a bottom hole assembly. And then rig configuration, so draw work speed, pump ramp up. And again, I mentioned pump ramp up. A lot of people are very blind to the fact that they have pumps that ramp up that was programmed by a guy in a rig up yard and nobody's touched it since. And in fact, the ramp up should be programmed based upon the mud properties and the hole properties and what can be tolerated in that ramp up. And then friction test. This is really important, is automatically gathering the pickup and slack off and torque for maintaining your torque and drag curves. And when the humans do it, there's inconsistency in how they do it from human to human. When it's automated in the manner that Novos have done it, you now have consistency in the application of doing those friction tests, and therefore the data has more value. You also can program it so they do it routinely and don't skip doing it when they've forgotten. And then their applications are becoming more extensive with planning, so upper and lower levels limits for drilling parameters. Downlinking, a lot of companies are doing this as well, to rotary steerable tools, MWD, LWD. So the method of sending the message down through the mud pulse is actually being automated. Automatically adjusting the auto driller to set points, so a more advanced automation process for drilling. Drill off points to achieve the best ROP. So you do a drill off test in a very consistent manner, collect the data, and then you can use that as input for your optimization of your ROP. Surge and swab, again, that's the envelope protection. And then they call this service Kaizen, which is a copy from the Toyota production system. But basically it's MD Todco providing an automation of MSE minimization, which means minimizing drilling dysfunction. And then they've commissioned apps from service company and then interfaces to operator modules. So they've opened up to bringing in more apps from other providers. And then also third-party apps, which is where you're getting the new startups and people bringing apps that help with their proprietary algorithms. And then their system actually seamlessly integrates with Amphion and cyber-based control systems, which are the two that NOV have been building for many years. And it integrates with their top drives, their draw works, their mud pumps. And also they've been doing a lot on robotics. So we've seen the equipment, the heavy equipment on the rig floor, but recently they've been using this Atom RTX, which is a manufacturing robotic arm, which is now being automated with different heads on it. And it actually supports the functions on the drill floor, so you can actually get a personnel-free drill floor. So here we're starting to see the real safety aspect, bringing in equipment from manufacturing and automating it to do multiple functions. HMH is a bit similar to NOV. It's a combination of maritime hydraulics, Worth, and Hydril. And they built their own rig operating system for their rigs. And it runs over their machine controls, and they call this one Deal. And applications that they say run through this operating system, and this was of about a year ago, so it's probably updated, and I put question marks here for what else there is. But stand building, so building offline, which saves time, of course, critical path. Drilling connections, which a lot of people are doing, is automating that to make it repetitive and quick as possible. Tripping, well construction sequences, they call it, but I put in here drill a stand. And this is the term a lot of people are using, where you can push a button after you've done the connection, and then it will go to bottom and it will drill down the stand, and then it will come back off bottom, and then it will go into the connection process. So drilling that stand is really important as it brings together multiple apps. So you're looking at rate of penetration, you're looking at steering, you're looking at envelope protection, you're looking at all these things occurring at once. And they've done well envelope protection as well. And SLB's new direction, I mentioned that they had this rig of the future. They invested a lot of money. They bought a number of companies that they pulled together to go this direction and offer it as an IPM service, so an integrated project management delivering wells with a fully automated system. And then they stepped back from that. So now the focus that I see them doing is closed loop rotary steerable systems. And here it's geometric steering, delivering vertical, tangent, and curve trajectories. And then they have a drill sync platform, which supports various typical automated functions. So now they have multiple apps as others do. So here, driller stand, as I mentioned, an adaptive auto driller. They were rate of penetration optimization. They were one of the first back around 2010, 2011. And downlinking, important one is to get the downlinks correct and automated. So you got to the rotary steerable MWD, LWD. Soft torque, which a lot of people have been using for many years. Tripping in and out, and then oscillator for steering the motor. So their system for steering motors downhole. Schlumberger and NOV have made a collaboration. I mentioned this earlier, but it's interesting that they stated this is to accelerate automated drilling solutions adoption by oil and gas operators and drilling contractors, and it combines Schlumberger's surface and downhole drilling automation solutions with NOV's rig automation platform. So this is a direct collaboration between a major service company with multiple apps and multiple algorithms with a rig building company that actually has an automation platform to run these systems off. And it's interesting, I found out that Schlumberger's, or SLB, sorry, is also collaborating with rig builders, Honghua, Drillmec Italian, Honghua and Bomco are Chinese. And I actually suspect, but I don't know for sure, that some of this collaboration relates to their IPM contracts, lump sum turnkey, in the Middle East, where they are using some Chinese rigs. So this may be the connection that's driven them to collaborate with the rig builders in order to bring their drill sync platform to drill those wells better, faster, and make more profit. And then they have drill plan and drill ops for operations. So they're planning wells digitally. They came out with a digitized drilling planning system 4 or 5 years ago. And now they've taken this to the next step where you can use it. You can speed up your planning process significantly. And then you can actually come out with a digitized well program. And that has an advantage because once it's digitized, you have the ability to then transfer it to the rig automated system in a digitized manner and get rid of PDF files, get rid of Excel spreadsheets, just super streamline the system and make it more accurate instead of people picking up and copying things. And so their idea is to drill the well with automated apps for the drilling dysfunctions, formation changes, repetitive tasks, etc. So it's combining these two systems together. Neighbors invested heavily in automation. I mean, as a drilling contractor with a lot of land rigs, they really went whole hog on this. They worked on multiple control and automation systems. They worked on integrating operating systems. And then they had this 3-tier approach to it, which I think is interesting because other people have done some similar things. And one is you start out with an app and you put it into the system in advisory mode. And as advisory, it takes data, processes it, and then it advises the parameters that the directional driller or the driller should use, and they can choose to use it or choose to ignore it. They are then the buffer between an app that may be incorrect and a proper application of the parameters for doing a successful operation. So once they gain the confidence in the app giving them good advice, they can switch to close the loop and go automatic. If they don't gain the confidence for a long time, then the designer of the app can go back and say, what's wrong with my app that they're not accepting it, therefore I must make changes such that these experts can actually accept what's coming out of it and then prove it up. And then they started a process to integrate with service companies' activities with the rig control system. So all these different activities listed here that could then be brought from service company apps into their rigs. And then machine automation and robotics. So they brought those into the system as well. And this has enabled them to really advance in automation and robotics. They purchased an advanced drilling robotics company, a Norwegian company, and then they've adopted this in a rig, which I'll show in a minute. They delivered one fully automated drilling rig to a US pad drilling for ExxonMobil, XTO. It was kind of a joint project. And it was a test bed to prove the applications of automation. Then after they did that, they retrofitted automation systems to upgrade on land rigs. And this way they could deliver automation at far less cost than a new build. And it was a combination of modular rig floor robotics and their rig operating system. So their their platform, their automation platform, over and above the control systems. And what's interesting here is the industry's looked at these two avenues. One, build a specially designed rig that's got the right sort of robotics for automation application, and the other is to retrofit to current rigs. And of course, the commerciality of it tends to favor retrofitting current rigs, although there have been some purpose-built rigs designed. So that's an interesting challenge as to which way things will finally go. And they have a family of automated drilling systems, so steering, stick, slip, activities input, recipe managers for the section drilling and things like this. This is a picture of their fully automated land rig. And you can see the robotic system right here that they bought, the blue system. So it's fully automated and it's robotic drilling rig. And what they accomplished was that the times this system did in West Texas for drilling approached the best West Texas performance. So they were managing with a fully automated system to accomplish what the best performance in the region had done. And one of the things to think about automation is if you accomplish the best performance, you can be repetitive at it. And therefore you can consistently deliver the best performance rather than have a variable type of performance, which overall isn't so good. And then this is a retrofit. And again, here you can see this yellow column, which provides the robotic structure within the land rig. It's completely hands-free pipe handling. Just think about that. It's completely hands-free. There's no crew on the floor or on the derrick. And this is in a retrofit rig. It does offline stand building, which is hugely important because you take it off the critical path. And it handles casing in upper intermediate production sizes. So it's not just a drill pipe rig, it's a casing rig as well. And they run their smart rig operating system over the rig system. And they operate both neighbors and third-party equipment. So third-party equipment on this rig is operated by the neighbor's smart rig operating system. And here's 3 diagrams on how they show that they apply their rig operating system to rigs. This is owned rigs. So the process automation is up here at the top level, casing running, slide automation, etc. Then they have their automation framework, their rig operating system, which sits over their standardized machine interfaces, their services, etc. And then that drives the equipment on the rigs. And on the right, they have a recipe manager, which is giving the formulation of the activities to be undertaken. And then they have a non-owned rig where they put an adapter in. So here they come in and they make an interface between their setup with their automation and their framework, their rig operating system, their recipe manager. And then they use an adapter to go to the third-party control system. And then there's another one where they replace the control system. So they bring in custom controls for the rig equipment. And here's an interesting slide that they presented in a present industry presentation of their portfolio of solutions, and they put in other ones as well. Now, I'm not going to say they're 100% correct, but it looks pretty accurate to me. So neighbors show that they're basically offering solutions. The green dots are ones that can compete on third-party rigs. So here's a drilling contractor offering smart services, offering rig cloud, offering automated systems that can run on not only their own rigs, which is very traditionally how things have been developed, but also on third-party rigs. And then H&P, Helmerich & Payne is the next one here, which Motive, their directional guidance system, has historically and always been working on anyone's rigs. But for the rest, their systems are designed to implement on their own rigs. Patterson is very much the same until you get to the integrated wellbore placement, which is their directional drilling service. They bought the service. It was already out there as a third-party service. And then precision drilling. Again, you see it's designed for their own systems. And Ensign is similar. It's designed for their own systems. Of course, NOV is designing it for their rig equipment, but it's now operating on third-party rigs as far as drilling contractors are concerned. So it works for different drilling contractors. And then they have SLB here, and I would also put Halliburton, which they didn't include. They look very similar. Of course, their services are offered to anybody, so it's on all sorts of rigs, but it doesn't get down into the rig equipment part of it, and it's missing some of the cloud aspect. And then this is a quick diagram showing you that they're applying to any rig. They're using Rig Cloud, so a cloud-based system, together with their smart rig operating system. And then they have these other nice buzzwords about what they're offering, but basically 50 plus drilling apps, 50 plus. That's amazing. They've made big progress. Their smart rig operating system deployments, this was a year ago from when I got this data. I can't find any updates that they've published. Some of these companies put these into investment presentations and then suddenly it disappears. So they've been on 113 neighbors rigs in the lower 48, Latin America, and Middle East. They've deployed across 14 third-party rigs, and then they put their apps on 96. And I think it's interesting, Citadel Drilling, which I think is about 3 rigs, are actually got the smart rig operating system and running neighbors automation. So here's a very small drilling contractor who's brought in the neighbors system and is now in the world of smart rig operating system automated drilling. And Halliburton's now using neighbors smart rig OS on subcontracted rigs in the Middle East. They just implemented this. They did a webinar and made a presentation on it. They've done it on 2 rigs in Iraq. So think about that. 2 rigs in Iraq are now automated drilling rigs. That's remote. And they also said that they expected to have a slow ramp up to get the benefits from it, but the benefits came immediately from the applications. And H&B built these flex rigs years ago. So this was back in the early 2000s. They had IDM controls, which later became Omron Drilling and Marine. And that's now become part of SLB. When SLB bought these companies to build their own system, they brought Omron Drilling and Marine. One of the things that H&P did a long time ago is the drilling of bits. And they reduced, there was work done with Schlumberger, which showed that the mean time between failure of downhole systems like LWD and MWD actually dropped significantly through the drilling process, which H&P had implemented. They purchased Motiv, and Motiv was acquiring, assessing, and deciding directional drilling parameters to advise the DDs, and then H&P closed that loop on their own drilling rigs. They purchased Magvar, which is a well survey quality company, due to the need to have accurate surveys in drilling long laterals. They purchased DrillScan. DrillScan is a modeling and dynamics experts company, and they are actually providing input into the systems and the methodologies that are being applied in these advanced services by H&P. And they brought in rig control experts that actually came from Omron Drilling and Marine Controls. So they brought the controls development in-house. Whoops. So they now continue to automate, and they call this Flex Fusion, which is a suite of services. So auto driller, bit guidance, remote support, drill string modeling. That's particularly from DrillScan and Stefan Menand, who's well known for his work in that. Precision Drilling, they adopted the NOV Novos system, and here's a complete list of the services that they're offering through that. So one of these is Pason's drilling automated system, which was actually developed with ExxonMobil based on the fast drill process, which is essentially looking at drilling performance using MSE and automating that. They do the friction test, they've got MPD, they do surgeon swab, reaming. So you're starting to see common applications coming across these different companies. They published some really positive results. A lot of people are not putting out a lot of their results except about consistency of operation. And one case, they increased from feet per day from 825 to 1,280. That's about a 50% improvement over 3 wells. And in others, they led to a 9.2% reduction in days drilled. Reported that they achieved that in 2021. The other thing I find most interesting is they're actually reporting strong revenues from their automation and apps. So currently they had at the time they had 18 apps commercial, and are reporting getting revenues by adding to their day rate for supplying those apps, which now shows that they've entered into the market with them. And this is their diagram showing alpha apps. So they have drilling with rig optimization. They've got 9 apps and they're developing 3 more. They got directional, they got drilling mechanics. And then they have some which they put under cost control, which is about their own equipment. Patterson UTI have a system they call Cortex, which is a central application platform. And they are actually, acquiring, assessing, and deciding for directional drilling. They're doing process automation of connection practices. They're minimizing drilling dysfunction. So they're going up the curve of applying apps through their automated system. Ensign have been working with digitalization automation for some time, and they have their edge rig operational system, which sits over their control systems, and it has cloud-based machine learning as well. They're looking to optimize drilling performance, and their apps, again, you start to see the repetition, MSV-based ROP optimization, automatic downlinking. And they made a special effort to develop a human-machine interface with drill down capability. So one button activation of a sequence. So they've made it more easier for the driller to use than taking an old system, an old display system, and just adding more stuff onto it, which is what people have done historically. They cleaned it all up and made it more intuitive. And Houseman have been doing a lot of innovative designs. They did their innovation tower with robotic handling systems, 180-foot stands. I think it's actually now up to 6,000 feet an hour. Automated tripping with interchangeable manipulators. They're actually doing studies on automation with Sintef out of Norway, looking at ways to improve the accuracy of predictive mathematical models. And then they've been working with a company they did a JV with, they call Houseman Well Technology, on automated directional drilling, rotary steerable tools, and casing drilling. So they're trying to expand their offering. This is a mock-up or rig-up of their tower inside a building, and you can see the manipulators that they have that reach out and move the pipe around. And they have a demonstration tower in their Rotterdam facility that we have, as DSATS, we've been to and we've seen it operating. And then they have a range of automated land rigs, and just running down the list here, you're looking at casing running, craneless rig up, automated. What I found interesting is they've shipped this HM150, which is a shallow drilling rig, to Shell and CNPC in Australia, which I think is called Arrow. And they're drilling coal bed methane wells. It's fast moving and there's no one on the rig floor. But I can't find out what happened to it after it got shipped there. I don't know if it's in operation or what's going on. And offshore, there are implementations. So you get Equinor, they are really pursuing automation across multiple activities. And one of the things they've been working on recently is automating mud treatment. So automating the detection of mud parameters and then taking that to automate mud treatment. Transocean has a joint venture with IntelliWell, and they are looking at integrating digital systems for well construction, drilling control, etc. And their aim is to accelerate the decrease of drilling time through using rig automation. I haven't seen too much published on what they're accomplishing with this, although they have said they've deployed their automation across 6 rigs. And then Noble has 2 Houseman drilling towers on purpose-built ships. And Maersk Drilling, which is now Noble, of course, is working with HMH, but they also formed Horizon 56 for digital workflow. And that's now a spin-off company that offers digital workflow for your drilling programs to bring them to the rig and put them into the digital system. And then offshore implementation, another one is Aker BP, Halliburton, and Maersk. And as I said earlier, this is something to really watch because they've driven digitalization of their well delivery process. And they've gone from 3 months' time to deliver a well program to under 2 weeks. And they're now actually scaling that up to digitalization of field development planning. So that's really important because when that happens, you get this digitalization at the field development level that then drops down to the drilling level and then drops into the automation. So now automation can be connected back to decisions at the field development level, which is where you can look at delivering more long-term life cycle value from the well than just being able to drill faster and save time. And service companies are applying their knowledge in apps. So they're developing apps that can deploy on rigs to improve the drilling process. As I said, they start out traditionally with advisory, and when they've got confidence in the system, they close the loop. Halliburton have a methodology of actually doing simulations of their systems in order to do verification. And then they do validation in the field by going to this advisory mode. And the advisory mode then is a buffer before you close the loop. Once you've confirmed the validation. They're automating their own downhole tools quite significantly. And they're implementing digitalized workflows for well planning, which are shortening cycle times and delivering these digitized well programs. And digitized well programs can then feed through the system into the automated systems on the rig. So you get this complete connection. Get rid of PDF files, get rid of Excel spreadsheets. And if I pick out on these companies, so Baker Hughes, what I've seen is they got 4 segments. So they're doing downhole with the rotary steerable tool. They're doing surface loop for downlinking instructions to the rotary steerable tool, so they can operate with mud pulse telemetry to bring data back up and then send down new instructions. They're doing drilling optimization with digital twin. This is really interesting because digital twins, people are talking about them, but here's Baker Hughes actually saying we have one and we're looking to get instructions from it for weight on bit, RPM, and flow. And reservoir navigation has become one of their big success points recently by doing automation, or even I'd say autonomous or almost autonomous directional drilling with their rotary steerable tool by going for automated reservoir navigation. And then they have a group called iTrack. So it's directional drilling, reservoir navigation, fluids monitoring. They're into that. So this has synergy with what the Norwegians are doing. And then tripping optimization. And again, you come back to the envelope protection. Don't damage the borehole, don't cause NPT. Hydraulics optimization, RFP. Stringer detection is one that's really interesting that they worked on, that actually when the drill string or the bit hits a hard stringer, and then it gets deflected by the hard stringer, that the system can detect this and back off the weight on bit or adjust the rotary speed in order to slow down and in order to slowly drill the stringer in a straight direction and without creating a dog leg. And that has been successful. And it's quicker to detect and quicker to react than the human being sitting there trying to watch for it all the time. And then Halliburton, they're doing digitalization and automation. So they've done this digitalized well planning system, which I've already mentioned. Now they're moving up to this field development, digitalized field development planning. They have a suite of applications for automation, which of course is coming out of Landmark and then their directional drilling group or the Sperry group. And then they connect it to some drilling contractors' rig operating systems. But the big one is that they have actually done this combination with Neighbors ROS in their lump sum turnkey drilling, as I said, in Iraq. And they've proven it's been very successful and they're advancing that program. And then I have to ask is, is what they're accomplishing with their systems, their apps, and Neighbors rig operating system obviating an industry interoperability standard? Or are there still pieces missing in the system that interoperability standard can bring to it, such as micro drilling states and things like this? And again, collaboration, which I've mentioned before. They have a Logix platform, so they're looking at steering the well trajectory and autonomously adjusting the parameters, mitigating vibration, so mitigating drilling dysfunction, and including collision avoidance. So this, my little wrap up here, which I'm going to quickly rush through, is what are the alternatives going to impact the route forward? And I call this forks in the roadmap. And who's going to be the integrator or collaborator? And I think what we've seen now is that the drilling contractors are automated or software platforms onto their rigs, bringing some applications and then enabling other applications to connect to their systems. And the most advanced ones are actually taking their automation platforms to other rigs, not only the ones that they build themselves. Interoperability, versus proprietary. And I think that the proprietary route really failed. And then what you're now seeing is that people are going interoperable. And then there are certain things that need to be accomplished. Is what's the architecture of that interoperability? The communication. So the data you're receiving, can you tell me something about the data so I know how to use it? And originally it was metadata. Then Eric Cailleux has been leading this work on semantics. And semantics is a story that describes the data. Where does it come from? What quality is it? Has it been processed in some way, yes or no? You know, you can take weight on bit. What is weight on bit? Where was it measured? How was it measured? What was the frequency? Was there a calculation done to do a correction? And then sensor and system certification. So how good are the sensors you got? How well are they maintained? And as the operators group on data quality has been doing a lot on this, and is coming out with an API 8 RP recommended practice for actually qualifying or verification of sensors on drilling rigs. And then there's an IADC sensor stewardship program that produced a guide on how to maintain your sensors. So this becomes important, especially when you go into automation. Cybersecurity, human factors. The big issue here for me is human machine interface. It's not just about getting the people off the rig floor. It's about giving an intuitive interface to the driller and something that he's able to use instead of historically the industry just adding another screen, and making his life more and more complicated. Drawstring telemetry is a big one. We're going to end up with these high data rate hardwire systems. Current one, which is induction connections, is 50,000 bits per second. You can get conductive ones, which are 500,000. Right now, there's 4 hardwire systems that I know of. 3 of them are prototypes. You look at mud pulse, EM, acoustic, we're at 5 up to 80 bits per second. So there's a huge gap between these two. And what that drives is the high data rates, you can do surface processing and send it back downhole for automation. With low data rates, the loop and the brains has to be downhole. And we're seeing a lot of development of the downhole brains and the loop because we're running at these mud pulse rates, these low data rate systems. Of course, with mud pulse as well, you have latency. The time it takes for the pulse to come up and the pulse to go down, whereas hardwire has lower latency. With hardwire, you start to look, is it an open system or a closed system? Is it like the internet, everybody can ride on it, or is it going to be a proprietary link? A long string versus BHA only. So once you get a hard wire, you end up with repeaters. And acoustic, you end up with repeaters. The repeaters can collect and add data from along the string. You don't get that from mud pulse. So how is that going to influence things? And then power down or no power down. When you get to these conductive connections, 500,000 bits per second, you get power down capabilities, which means you don't need to have turbines, you don't need to have batteries downhole. And then the question I raise is, would a new technology emerge that's going to fill this gap between up to 80 bits per second and 50,000, 500,000? And I think that's unlikely. And I think that what's going to happen is we will see the hard wire will have some niche applications, particularly in areas where collecting formation data in real time drives decision making for field development planning. And when that happens, you're going to take the hardwire system, pay the extra, and manage the reliability. Because once you lose one connection, you've lost the whole link. So reliability is one of the challenges. And then I think for routine operations, you're going to find that we're going to be living in the world of mud pulse, EM, and acoustic. So I think that's going to be interesting to see how that plays out. And of course, as we get digitalization of field development planning and we get faster development loops, then that real-time data from drilling one well may have a huge impact, and you'll see an uptake on these hardwire systems. Asset renewal or replacement, I basically discussed that before when you look at the fully automated special rig from Neighbors and then the application to current rigs. And the industry tends to resist coming out with a completely redesigned rig, and it's a question, how does it fit into the payment schemes of the business model? And often there's not enough money there to do it. I mean, some of the successful ones in the past were done by a combination of operator and drilling contractor against a fixed term contract that would pay off the investment to do it. But I think we'll see more retrofits than we're going to see new designs, unless we end up with people taking the view, as shown by Walt Aldred from Schlumberger many years ago. You look at dishwashing and you say, let me observe the process, let me define the objective, define the functionality, and I'll redesign the equipment to suit the application, and bingo, I get a dishwasher. But often people go and think in drilling terms of, I'll make this little robot with a brush and a bucket, and we'll go ahead and do it that way. So if you actually take a systems engineering solution and then you design based on automation, you're going to end up with a box that has jets of water, that has heating systems in it, and not with a little robot with a brush in his hand. And the question is, can we take that jump across? Is there an advantage to do it? And is there a way to commercialize it? So the value proposition, I think, has been developed so far is the safety, removal of people, efficiency. And I'll tell you, consistency of repeated operations makes improvement in performance. You just have to look at the long tails on connection times. You know, it's 2 minutes, 2 minutes, 5 minutes, 2 minutes, 1 minute, 50 seconds. So you get a little few seconds on the upside, you get minutes on the downside. If you get rid of the minutes on the downside, your mean goes up. Your mean gets quicker. Process safety, borehole envelope protection. And, you know, the stringer thing is really important because the system can catch stuff earlier. And of course, influx detection. And then reduction of cognitive load on drillers. You know, take them up to the supervisory control so that the routine operations are being done for them. And I mentioned, yeah, improving influx detection. Oh, this is one quick one to close. This was a system in Australia. I think it was in Brisbane. So they had a cargo handling facility. It's routine stuff, right? It's containers, big ships, big containers, big cranes, trucks, boom, move it around. They put in autonomous equipment. So the equipment that moved it around and the cranes, and they implemented remote control. And the effect was the productivity went up 18%. So you can imagine that's a huge impact on this situation. Maintenance down 27%, 27%. And fuel consumption down 22% for all the people who want some ESG. And one of the reasons was they turned the lights out because these autonomous systems didn't need to see in the dark. So they ended up, they said, this is an autonomous wharf, not just autonomous vehicles. So you take remote, you take autonomous equipment, you put them together, you're going to get an autonomous system instead of just autonomous vehicles, autonomous equipment. Whoops, that's the end of my presentation and I'm overrunning, I'm sorry.
Excellent presentation, John, and very powerful in different aspects because it's a lot of idea and a lot of application in the industry. I encourage the people to give the question in the in question and answer, please. Meanwhile, my first question is, who should push for automation in the industry? The operators?
Ultimately, the operators pay the bill and get the value. So ultimately, in the end, I think it's a value proposition thing. If the proponents of it can demonstrate the value proposition to the operators in terms of performance, so reducing well cost, but also in terms of the quality of the well that they deliver and the risk they're taking on getting an overrun on cost versus a predetermined cost, then I think you get the operators to invest in it. I mean, when it first came out, or I said the early stages in the US on land, drilling contractors were taking on automation because it was competitive advantage. So it's a very competitive rig landscape. And when a rig can come along and say, I'm a top tier rig, and I have automation, they can beat competitively a top tier rig without automation. But then you see that precision drilling presentation where they say they're now charging for it. So it's gone from being just a competitive advantage to something the operator is willing to pay for. So yeah, the suppliers have to show value proposition. And in terms of the quality or the value of the well in terms of production of oil and lower OPEX, as well as reduction in cost and earlier completion, and then get money back for it from the operators.
The next question is, you talk about collaboration. How to deal collaboration and business for the different service company?
Sorry, how can the collaboration and the competition?
How can be deal with collaboration and business? Because if you have some competitive advantage between another service company, and then you have to collaborate together in order to have the same thing. So how to deal with that?
I think that the slide I showed on the amount of collaboration going on is showing a change in the industry. And I think the change is partly related to attitude, but it's also related to digitalization. If you're going to go into full board digitalization, you're going to be using someone else's data. You better go talk to them about what the data is, how they acquired it, what the quality is, what the frequency is. So how can I actually use it? And de facto, you end up having to collaborate. And when you collaborate, I think you're ending up with a better overall result than when you try and go things on your own. I mean, in the past, the industry was always hiding stuff, and they were closing access to control systems, etc., because they wanted to prevent someone else coming in. It inhibits progress. And I think the world has changed in the way that collaboration works, that you get progress, and our industry is now demonstrating that. And especially, I think, from the software as a service companies coming from elsewhere into our industry is showing us a different methodology of doing this.
Can you explain a little bit about what we are doing from DSATS in order to push that?
The big thing in DSATS right now is DWIS. And as I say, go and have a look at the d-wis.org website, and it'll show you a lot of what's happening. And they have regular meetings, and volunteers work in those meetings. And they are having a big impact. They're bringing in the ADCS suppliers into this demonstration. So companies that are in the world of applying automation are now going to get involved in that DWIS, DSAT subcommittees demonstration to show how it can all link together. So that's a big plus. Yeah, we do webinars and do symposiums and things to share information. There is a DSATS website which you can go to and have a look and see what's happening.
Okay. Well, I think that we don't have so many questions. It was an excellent presentation, John. Thank you for your time and your dedication for this. I also want to thank to the Argentina SPE section and Fernando Tuero, who is in charge of the presentation in the chapter. And thank you a lot. Estás muteado, Fer.
Okay, thanks, John, very much. And just one thing, that the audience was very stable through all the presentation. So it seems like the interest it was from start to end. So that's great, John. And there's a lot of comments in the chat that you can read them afterwards, that they are all praising about the good presentation. So congrats.
Okay, well, thank you. I enjoyed putting it together.
Someone asked me if the presentation can be available, so I can send you the email list of the attendees, and you can share the presentation if you like, John.
Okay, yeah.
And I have some people that they couldn't be in contact, so they asked it when they can have available the recording.
Okay, then we are going to upload it to our YouTube channel if John it's okay with it.
Yeah, I'm okay with that.
Okay, thanks.
Thank you very much, John. See you next.
Okay, well, thank you for the opportunity. Take care.
Bye-bye to everyone.
Take care. Bye-bye.
Good week. Bye-bye.